All right. Are we ready? You ready to see it? So the purpose of me doing this problem, all right? Purpose of me doing this problem is just to show you again how this just keeps cranking higher and higher level. All right? Tightening the screws. So when I look at this, I think, all right, I've got a cosine down here. The derivative of cosine is negative sine, right? Or I could say I have a sine, but it's 2x, right? But then there's a light bulb. That's a double angle identity, right? So I know that from this I can get some sines and cosines. Let me just start with that. What if I did this? Get everything in terms of sine x, cosine x, like this. Now remember, I haven't worked through these, so that's just my first instinct there. So from here to here, that's double angle identity, right? Now, I said that derivative of sine is cosine, derivative of cosine is negative sine. So it seems like I could maybe choose u to be sine or cosine here, right? If I choose my u to be sine, where's my cosine? It's here and it's down there, right? And it's all complicated down there. I don't like that. If I choose my u to be cosine, the derivative of cosine is negative sine. That's up here, isn't it? All kind of by itself. So let me try this. Let me go and rewrite the integral. 2 is going to come out. I'm going to put the cosine x here over 1 plus cosine squared x. And then I'm going to say times sine x dx. Does everyone agree that's the same problem? Any questions on what I did?
You got the derivative of the bottom.
I haven't taken derivative of anything yet. All I'm doing is rewriting the problem. I'm pulling that sign out with the dx so it's nice and kind of in my face here. And then everything else is right here. And I'm about to make the substitution. U equals what?
Cosine x.
Cosine x. So u equals cosine x. The derivative of that is negative sine x dx. And so I have what here? Sine x dx, but here's negative, so how can I fix that? Multiply negative 1 on both sides. So negative du equals sine x dx. So I'm going to replace this with what? Negative du. And I'm going to replace every cosine I see with what? Cosine x with u, right? All right, let's get this going. And I'm going to pull that negative on the du out in the beginning. Can I do that? Is that too much? So this becomes, the 2's already out here. That negative du that's going to be here, the negative is going to come out. So negative 2 integral, what's cosine x again? U over 1 plus u squared du, right? Yeah, this is from that negative. Is that all right? That's where we are, aren't we? Do you have a formula for that? I don't think you do. Yeah, I pulled that negative, you know, because this negative du, I just pulled it out in the very beginning. So you see I'm starting to kind of like do more steps at one time now? Yeah.
Could you just rewrite that as like u over 1 and then 1 plus?
U over. Can't do 2 because we have two terms on the bottom, 1 on the top. If it was the other way around, you could split it to 2. So look, hey, look. Here's the thing about integration. Substitution works, right? We've seen it works in certain problems, right? There's nothing that says you can't make 2 substitutions in one problem. So let's start all over. Do you see something in its derivative?
Yeah, u squared.
What's the derivative of u squared? 2u, right? I've got u up here. I'm off by a constant. Go for more than just that, though, for your substitution. How about 1 plus u squared? What's the derivative of 1 plus u squared? Still 2u, right? Do you see that? I'm going to do another substitution, but I can't use u because I already used u. So I'm going to use a different variable.
2 back in?
2's just going to stay out there the whole time. All right? So here comes my second substitution for this problem. I'm going to call, you want to go v or w? I don't care. I think I'll do w just because people don't like my v's. All right? Yeah. I exaggerate my v's like this because I used to confuse them with my u's. Those are my u's. So people think my v's at some point start to look like r's because I do them real hard like that. So I'll just go with w. All right, so w equals, what was it we're going to use? 1 plus u squared. We're going to grab the whole denominator. dw then equals, now be careful here. What's the derivative of 1 plus u squared? 2u du. Instead of like, 2x dx, it's 2u du because the variable is u. Pardon me? Right here?
Yeah, but like the negative.
Back in the problem, we replaced sine x dx in the integral. We replaced it with negative du, didn't we?
Right.
And that negative on the du, I slid it out in the front and put it on the 2 that was already out there.
So where's the 2u come from? dw?
Oh, derivative of u squared is 2u. Derivative of 1 is 0. 2u du. That all right?
Yes, sir.
All right, so I'm gonna kind of work with this a little bit. Sorry, I misunderstood what you were talking about there. I'm rewriting the integral just so everyone can see this. Here's the negative 2 out there. It's 1 over 1 plus u squared u du. So all I'm doing is just moving that u to the side here so you can, again, match this up with down here. Actually, no, down there. And then this is going to match up with this. You following me or not? I'm off right here, right? I have u du here. Here I have 2u du. So what do I need to do on both sides? 1/2. 1/2 dw equals u du. So you ready to rewrite the integral? Wait, go ahead. Ask. What's Leonardo's name in that movie? It's Rose and who? Jack. Jack. You all right? Okay.
And whoever doesn't drop are the lone survivors of the typing thing.
That's right. All right, so here comes my new integral. My new integral is -2 integral of 1 over 1 plus u squared. 1 plus u squared was what? W. And then times u du, which is really for us half of dw. That's just barely on camera. Okay. So now where are we? Pull that 1/2 out. So that's just going to be a -1 out here, isn't it? And then 1 over d integral 1 over w dw. So we're at negative integral 1 over w dw. And that's a formula, isn't it? Natural log w, but then there's a negative in front of it. Absolute value w, plus a constant. Now, what was w, though? So this is natural log of 1 plus u squared plus a constant. But what was u? Cosine x. So equals negative natural log of 1 plus cosine, not 1 plus, yeah, 1 plus cosine squared x, close off your absolute value, plus c. Yes. Repeat what? Okay, so what was w? So go back to where we made our substitution. W equals 1 plus u squared. We did that substitution, so you just go look back in the work. I already erased it. So that replaces with this. And then back in your work, we made, very beginning, we made the substitution u equals cosine x. So that's here. And so it replaces.
How come the negative doesn't distribute to the c?
It doesn't matter because the constant is a constant. I'm not telling you if it's positive or negative.
Okay.
So the negative could go to there, but it's still a constant.
Okay.
That's a good question, but this sign out here never affects this number. It's just something.
Plus minus 3.
That's right. It could be plus or minus anything. So that was the first problem where not only did we have to use a double angle identity, right? We also had to use substitution twice. Now, is that the only way to do the problem? I don't know. There might be another way. That's the way that I saw it, and so that's the way I did it. Okay, we still have half an hour.
You got some sign-in sheet today?
Yeah, thank you for reminding me about that. You know, the thing is, I told you this already. Like, this is Cal 2, man. If you're not coming to Cal 2, you know, whatever. I mean, I'm videotaping it, so I guess you don't have to be here, but...
There's no audio, right? Is it really? Yes. I couldn't hear it.
Because Mike was teacher.
You couldn't hear the audio?
I could hear him even
When? When?
For the first day I came to class, I didn't come the first day because I was absent. So then I looked at your videos and I watched them, but it was like mine style, I guess.
No, the video, they should all have audio. I don't think any of them didn't.
One from Wednesday had audio. That's not what I watched.
I think they all do.
I'll check it out.
I try. Sometimes my batteries die, and this doesn't give me any indication that it's dead. So,
I'll try it again. I didn't hear it.
Watch him doing.
all right, this is 33. Okay, so just like the previous problem, it was the first time that we had seen that certain sort of double substitution. I'm going to modify this problem slightly. I'm going to make this to the 70th power. Only because, well, what I'm about to say. We have the power rule, right? The power rule allows you to take the antiderivative of powers if they're by themselves, x to the third power, x to the fifth power, even x to the 1/2 power. Now, if this x wasn't here, theoretically, we could do 2x plus 5 times 2x plus 5 70 times, multiply it all out, collect like terms, and wouldn't we have a bunch of x's to powers?
Yes.
And then do each one using power rule? I put the 70 there to force you to not want to do that, all right? Like if it was a 7, you might be like, oh, I'll just multiply that out, and I'll be all proud of myself because I can do that, you know, and spend half an hour multiplying that out. But if I make 70,
No way.
you're not going to want to, right? So I'm forcing you to do something else. So let's make a substitution. Do you see something and its derivative?
Yes, x plus 5 and x.
If u is 2x plus 5, what's its derivative?
X.
I think you said u is 2x plus 5, right? What's the derivative of 2x plus 5?
X.
2.
Oh, yeah, 2.
2, right? You don't have a 2. It's okay, though. If you don't have a 2, you're off by a constant. But you don't... You see something, you don't really see its derivative. It's there, but it's just a number, right?
Yeah, you got x's.
But then I also have this x out here, don't I?
Yeah.
So hang tight. You ready? Here we go. This is just one of those problems you're just going to have to watch it first. Let's make that substitution. I'm picking the most complicated thing I can without picking too much, right? Like I don't want to pick 2x plus